Hello and welcome to the webcast, 3D BIM for Substations, Driving Efficiency from Design Through Operation and Maintenance. This presentation is being brought to you by Bentley Systems. My name is Kristen Wright, and I'm the Senior Editor of Power Grid International and Electric Light and Power magazine. And today it's my pleasure to join you for this webcast. Before I introduce our speaker, I'd like to share a few tips with our audience to ensure you have the smoothest experience possible. The slides for this presentation will be pushed to your screen automatically. For better performance, we suggest that you close any other applications you may be running on your computer. If you have questions for our presenter, you may type them into the Ask a Question area at the bottom of the viewing console. And we'll try to share those at the end of our presentation, and you can type a question at any time during the webcast. Today's presentation is being recorded and will be archived on our website. And that's great news because if you missed something or if you want to share it with your colleagues, you can access it beginning in 24 hours at www.elp.com. Penwell also offers seamless access to both live and on-demand web presentations from your smartphones and tablets, so you can always be in the know on the go. And now I'd like to introduce our speaker. Mr. Chong Quinn Wai serves as General Manager of Research and Development of Pestech. He graduated from University Technology Malaysia in 2002 with a Bachelor of Engineering in High Voltage Engineering. He started his career in the group as an engineer in the D&D department. Within 7 years, he was promoted to Senior Engineer, Associate Manager, and Manager of the team, where his responsibilities included circuitry design of substation control and protection systems, handling of turnkey substation projects, substation engineering and design work, as well as management roles that included project management and departmental management. In 2011, he was appointed GM of D&D, a position he holds to date. Thank you for joining me today, Chong, and now I'm happy to turn this program over to you.
Hi, thanks, Kristen. I'm Chong Quinn Wai, the General Manager of Design and Development Divisions for Pestech and Berhad, Malaysia. Hi, thanks for your time to learn about 3D BIM for substation, driving efficiency from design through operations and maintenance. We think BIM will become the DNA for future constructions. The undisputed benefits of building information modeling, which in short we call BIM, are motivating fundamental shifts in the design, constructions, operations, and maintenance of utility infrastructure. However, many utilities and EPCs are challenged with transforming their business process to realize the potential. So in this webinar, I'll try my best to describe my company transitions to intelligent substation design and the corporate BIM strategy. This presentation will illustrate how a substation design process centered on an intelligent 3D BIM model enables asset lifecycle information to become a standard project deliverable. I hope that by the end of this presentation, you will learn what does BIM mean for utilities and what are the benefits, the BIM model for substations, and intelligent substation design as a BIM enabler. So here is a presentation outline. So we will start with a brief introduction about my company, Pestech, and some of the major project experiences in domestic and overseas markets. This will give you some idea about the company background, its core business, and the industry of where the company is involved in. Next, under the topic of BIM for electrical utilities, I'll talk about the engineering efficiency limitation faced by most of the EPC contractors in Malaysia, and how BIM can be the remedy to drive the engineering efficiency. Also, I will touch on the challenges of BIM adoptions in Malaysia, followed by Pestech strategy in 3D BIM model for substation utilities. Then we will talk about the substation intelligent tools, which enable the BIM implementation. It is very important for us to have an appropriate substation design tool, which can be integral to the entire project lifecycle until the stage of operation and maintenance. Finally, I'll end with the conclusions. So let's start with the company introductions. Okay. In 1991, Pestech Sdn Berhad was incorporated as a power grid builder and a trader in electrical equipment and supply base in Johor Bahru, Malaysia. It is now a wholly owned subsidiary of Pestech International Berhad, PIB, an integrated electrical power technology group of companies listed on the main market of Malaysia Stock Exchange in May 2012. The company was expanding throughout the years, and now we have offices in several locations in Malaysia, such as Shah Alam, which is the headquarters, Sabah and Sarawak. To serve our regional customer better, we also set up offices in Cambodia, Laos, Sri Lanka, and Brunei. Today, Pestech Sdn Berhad focuses in two major business sectors. First is the EPC contracting business for high voltage and extra high voltage substation, transmission line, power cable system, including the civil works. Second, we are also assembly and manufacturers for products such as control and protections, panel, in short CRP, RTU, which is remote terminal unit, NER, the HV isolator, SCADA, and telecommunication panel. As of today, our product and services has As of today, our product and services have reached most of the ASEAN countries, such as Indonesia, Brunei, Cambodia, Laos, Vietnam, and Myanmar, and also countries as far away as in Sri Lanka, UAE, Korea, Australia, Papua New Guinea, Mali, Ghana, and Tanzania. And here are the major clients to the company, which we have Tenaga Nasional, which is the utility, the major utilities in Malaysia, and Sarawak Energy. So next, I would like to share some of the photos of our major substation project in both Malaysia and overseas. Let's start with Malaysia. So this is a 275-33 kV Murun Junction substation located in Sarawak, Malaysia. This is our recent completion. And this is a layout view of the substation. And next, this is also another recent accomplished substation, which is called OM 275 kV, 35 kV substation. This is a sectional view of the substation. And this is a reactor and capacitor bank of the substation. And next, I will show you the control and protections panel, the switchgear, which are manufactured in-house and delivered to the substation. So the third project which I would like to share is a GIS substation, which is located in Manjarala, Malaysia. This is a 132 to 33 kV GIS substation. And this is how the substation looks like, the GIS equipment looks like. Next, we have TMB 132 33 kV Financial Center, another indoor GIS substation. And this is a building. And this is ABB GIS switchgear for the 132 kV. Next, I'd like to share about our major substation project experience in overseas. So I'd like to start with the CEB, which is a Sri Lanka utility, and that's where we built 132 33 kV Paliata substation. And these are the panels located inside the building. And next slide is another accomplishment project complete in Papua New Guinea. This is a 132 kV Irap and Hidden Valley substation. And this is a helicopter view of the substation layout. And next, another substation which we accomplished is in Ghana, a 170 to 12 kV iron Foley substation. And these are the photos about the substation. And what we can see from this slide is a 115 to 22 kV Kampong Cham substation in Cambodia. This is a night scene of the Kampong Cham substation. Next, this is 230 115 22 kV North Nong Peng substation in Cambodia. And this is a very nice helicopter view on the substation. And this is a sectional view of the substation where we take in the evening. And this is the equipment, the control protection spanner, the substation automation system, and switchgear delivered in this project. So next topic will be BIM strategy for utilities. So basically, the utilities EPC contractor in Malaysia are facing huge challenges to increase the productivity, quality, and value. There are many problems dealing with the EPC, such as the cost overrun, project delay, productions of low-quality product, intensive labor, as well as still using old technology. So one of the engineering efficiency issues they faced by most of the company in Malaysia are generally we are still implementing only fundamental computer-aided drafting, which we call CAD. With CAD, we still have to involve in manually create, maintain, and update the design in 2D drawings. Draftmen are recruited to associate the substation design engineer in drafting the substation equipment, steel structure, and etc. Before the designer can use a drafted object into the design drawing. So in order to save time, designer copied the drawing from one project to the other project and adapted them into the design. However, this is not really saving time because they actually spend time browsing through past projects to get what they need. As the company doesn't have a single environment of database capture for all the design drawings, engineers spend time to search among their colleagues. Also, the CAD doesn't come with any intelligent functions. Therefore, the designer has to manually carry out the crash and clearance check, has to manually draft the lightning protection coverage in the layout and section drawing, and they have to manually assigning the cross-referencing, wire number, and so on and so forth. So as mentioned, everything is done manually, and this has created great pressures if there is necessary to make any modification due to factor which is external to the designer, such as the change of a substation equipment, or any adjustment of substation layout and section, and etc. And there's also internal factor such as lack of sufficient and experienced qualified personnel, and etc. This is the biggest engineering efficiency challenge faced by our company as well as other EPC players in Malaysia. Next, as there's no automatic document generation function with the CAD, designer visually inspect the 2D drawing to count the equipment. So they have to estimate the material quantity and then enter into a separate spreadsheet for procurement. Pestech is also a manufacturer of control and protection panel, RTU, and communication panel. We used to generate BOM in manual way too. And this process is very time-consuming, inconsistent, and prone to error. Also, it is highly depending on the experience and competency of engineers who put up the bill of material. For instance, we have a project in Morun Junction substation, which I show in the first photos. There's an incident of designer wrongly calculate a quantity of flexible conductors that lead to the material shortage pre-or commissioning. Approximate US $40K was spent just to air freight the conductor to site so that the project can deliver on time. So this is a loss of the project, and this could be avoided if the BOM is generated automatically and the designer just have to double check and confirm. As the EPC contractor are still working with old technology, information exchange such as design parameter, vendor equipment, drawing, design deliverables, were scattered among project stakeholders, and sharing of this information is highly inefficient and mostly involve a lot of documents and drawings. And this is the third issue faced when it comes to the topic of engineering efficiency. With some of the company doesn't have any single database storage to capture all the engineering information. All sort of information is distributed in various engineer computers. This means loss of work by accidentally delete of the file on the engineer computer could be a disaster. This means major reconstructions of project deliverables are required. Also, having a wrong information in the construction process, such as working with outdated files, has serious impact because in a construction project, information is perhaps the most important construction material. Any rework is costly and time-consuming. Therefore, there's a need for managing the information properly to ensure all parties in the construction receive the right information. In a lot of substation projects, information actually degrades faster than the facilities degrade. This is due to lack of document control over the drawings and O&M documents. It is very common that massive time is spent in collecting as-built drawings and O&M documents for project handover. And in fact, in some of the projects, O&M documents would take years to deliver or never deliver after the substation is commissioned. These are all because of poor information management. Besides, we have also external factors which cause the engineering efficiency deteriorate. So for example, a project has shorter execution time and basic detailed design has been identified as a part that can be shortened. So the pressure is always on the designer to come out the design in the shortest time possible. Likewise, during the substation design, modification of design is required. This includes changing of the substation site, changing of equipment, changing of the work scope, and etc. Any modification from minor adjustment to major changes will increase the design times and reduce the efficiency. So given the challenges and limitations above, Pestech has decided to move forward by adopting the Building Information Modeling BIM implementation in substation design. So among ourselves, we ask, what is BIM? So in Pestech, we define BIM with three questions. So the first one is why BIM? Because BIM is an emerging technology deployed in the design, construction, and facility management. The next question we ask, what is BIM? It is a virtual representation of a project containing all information required to construct by using computer and software. The next question we ask, how does BIM work? BIM integrates technology and process to enable the efficiency life cycle management of facilities. So this is the definition of BIM among questions. Upon observing potential benefits of BIM, we have conducted an internal study on this topic, and there are three major advantages being identified. The first advantage of BIM is it allows substation 3D modeling. The substation 3D model is definitely a wow factor in bidding a substation project. Nevertheless, the real idea of substation 3D modeling is to make easier to visualize and document the substation plans. Even though some individuals consider themselves good at visualizing substations based on 2D drawings, but the consensus is that 3D visualization tools improve everyone's capacity to understand what result the substation will look like and to help determine which design option is the best. In another word, this enables the stakeholders who are not design experts to be involved in reviewing detailed design the construction processes, and the future operation and maintenance activity. In 3D modeling tools, the designer can better visualize the design with the built-in features like clash detection and clearance check, and to perform any physical measurements. The intelligent function in the 3D modeling tool also support automatic generation of documents such as BOM, part list, and etc. With the latest IT information technology, BIM information can now be embedded into a graphic model for usage in engineering, construction, operations, and maintenance. This is definitely the most revolutionary way to review the substation design. The second advantage of BIM is the BIM implementation with the collaboration tools can provide a common data environment and ensures information mobility for engineering information used in the design and construction of infrastructure projects. Therefore, it helps to achieve organization agility in managed environment by creating and managing ongoing work effectively, where the right people quickly and reliably accelerate work in progress using the infrastructure tools and workflow of choice. We used to call this the best engineering practice. With a single source of truth for all project documents, it avoids the work saved in the respective engineering computer. So this will avoid the loss of data in respective engineer computer. Also, the BIM implementation with collaboration tools can maximize value across the enterprise by informing the stakeholder, the project stakeholder, in a more consistent, timely, and predictable manner. With this timely and actionable participations from all stockholders, there will be no longer working with outdated files, as most of the design or construction issues are resolved quickly and effectively in a closed loop. And the third advantage being identified is the life cycle management. And this life cycle management allows a wealth of information being handed over for life cycle management. For a project completed with BIM, there is a single trusted and secure environment that contains the critical engineering data needed by the asset management and operations team. This information is easily made available from project handovers to the asset management team. So moreover, this data can be utilized by the asset management solution as and when needed. However, in Malaysia, BIM adoption is driven primarily by the primary sectors such as the housing developer or construction company on the big development. And they have already realized the significant benefits to be derived from intelligent adoption of BIM. And BIM concept has not been adopted in electrical, utility, which are government-linked companies in Malaysia. And having invested for BIM application, there's no assurance that the company could secure a job. The possibility of recovering ROI is uncertain since the initial capital outlay to implement BIM is high and could affect the project cash flow. Therefore, according to the Construction Research Institute of Malaysia, cost is a main barrier for Malaysia company to adopt BIM in construction. Investment is required in the following. First, the hardware and software for BIM. Second, to enroll the staff for training. Third, to employ the BIM-capable personnel. And fourth, to obtain and maintenance of software subscriptions. Also, the lack of knowledge in BIM was another barrier. BIM is new too that many have little or no knowledge about it. The learning curve and time taken of the staff to understand, apprehend, and hands-on BIM is a main concern. Also, the readiness to change from the traditional approach to BIM require high cost of investment, clear consensus as how to implement and use BIM. Despite the productivity and economic benefits of BIM to the SMEs, the in-house technical staff sometimes are not ready to be trained, not IT savvy, and organizations are facing shortage of reliable workforce. But despite all these barriers concerned by other EPC contractors in Malaysia, Pestech has set aside all of them and have placed financial investment in Bentley Substation and other Bentley tools to be the leader in Malaysia and Southeast Asia for BIM design for utilities. In fact, we have initiated a pilot project, which by end of the project, a turnkey fully BIM outline model will be provided to the customer. So asset performance management is another growing area for Pestech, with our setup of Pestech Technology Sdn Bhd as a subsidiary of asset management solution provider. The BIM outline model can now be integrated into the asset performance tools easily. Next, I would like to illustrate the BIM model or the Pestech BIM model for utilities. So we categorize it into 4 phases. So phase 1, which is a substation electrical design, is a stage or is a phase where our substation electrical design is done with the substation intelligence tools. And this project, or this pilot project, was initiated in 2011 and it was accomplished in 2013. Phase 2 is a 3D physical design, which involves the substation primary design. And this was just initiated in May this year. And we look forward to deliver the pilot project in middle of 2015. Phase 3 is the implementation of a collaboration tool, or we call it engineering information management tool, which we are going to initiate in October this year, which is next month, and it is targeted that the full implementation with this revised design workflow with the substation database and O&M database built into the project, and this will take place in the first quarter of 2015. It is in our expectation that with the successful implementation of phase 1, phase 2, and phase 3, by middle of 2015, all subsequent projects after that will be delivered in BIM outline model. With the BIM outline model, the substation owner can then determine if they would opt for an asset performance management tool, since a project database that contains the critical engineering data needed by them can be easily integrated into their asset performance management tools. And to ensure phase 4 of this BIM model being executed successfully, effort is needed to convince the clients by creating awareness of BIM benefits among them. So without technology, the implementation of building information modeling BIM will not be as successful, as the technology will complement the company and the people who are ready in implementing BIM. Therefore, delivering of BIM is highly dependent on the intelligent substation design tools that we deploy. First, as a wow factor in bidding the construction project tender, the software provides a very friendly and convenient way of generating substation layout just by completing a single line diagram. The layout can even be produced by the sales personnel who doesn't have in-depth drafting skill. And secondly, Bentley Substation is the only integrated software product for intelligent electrical and physical substation design. Bentley Substation is the only software we found in the market that really integrates the substation primary design and the secondary design. And Bentley Substation combines the physical and electrical design in a single standalone product. Because of this, the designer can produce a single line drawing or single line diagram, a 3D physical model, which is the substation layout and sectional view, the protection and control schematics, the panel layout, the wiring diagram, and more in a unified environment. And this eliminates the needs for multiple separate applications and the needs to re-enter the same data. So additional, the integrated design approach reduces the amount of manual coordination to keep the substation primary designer and the secondary designer consistent, while also promoting a greater collaboration between the two disciplines. In most of the cases, 3D drawing is not being implemented in substation design because of its complexity of using the required software. However, Bentley Substation offers a new and easy-to-use 3D tool. And Bentley Substation comes with an advanced modeling functions to design, analyze the grounding grid, the lining protections, the cable set, the clash detections, and clearance check. And Bentley Substation also automates the traditional time-consuming tasks such as the generating of the construction drawing. And with Bentley Substation, the designer simply defines a view of 3D model, and the software can automatically produce a construction drawing. And also, in the 2D or 3D view, both update dynamically, whenever either side is changed. Also, Bentley Substation comes with an intelligent schematic diagram cross-referencing, an error check, such as duplicate device identifiers, over assignment of contacts, wire break is healed automatically, and so on and so forth. And Bentley Substation also offers the automatic generation of documents, such as the bill of material, terminal plans, cable diagram, wiring diagram, and etc. Many people can benefit from access to BIM models, but with the wide range of file formats and the differing uses of them across different industries and different disciplines, sharing them with everyone who could benefit from them is virtually impossible. Therefore, the iModel are a great way to share BIM models, as it allows BIM models to be custom, tailored to support the needs to access them anywhere with only the information each participant needs, while supporting a unique workflow and a standard for each project with the right level of detail. For more information of this iModel, we can actually refer to the Bentley's website. Last but not least, we think the selection of intelligent substation tools is highly dependent on its interoperability to meet our BIM objective. We need a software with the ability to exchange data at different phases or different BIM maturity level. We found that Bentley Substation as engineering design tools can be complemented with other Bentley data management tools like Bentley ProjectWise, the asset management tools like Bentley EB, that tie together with our procurement and work ordering tools such as SAP, and then the performance management tools like Bentley AssetWise or Ivara to provide the turnkey fully BIM outline model to the utilities. Changing from traditional approach to BIM implementation is not an easy process. It requires a change in management strategy, a commitment to ensure a successful transition. A software company who can support the company BIM strategy is very important too. So in conclusion, Pestech had committed for the change from traditional approach to 3D BIM implementation, that enabling completion of project within the three important parameters, which is the time, cost, and the quality. Also, Pestech have developed the concept of a turnkey fully BIM outline model to the utilities and is currently working through a pilot project which is targeted to complete by mid of 2015. To achieve the above, Pestech have carefully selected the experienced BIM software company as a partner to provide solutions from engineering design authoring tool, engineering information management tool, and asset management and performance management tool. Yes, this is the end of the presentation. Thanks. I'll pass it over to Kristen.
Thank you, Chong. I'd like to take this time to remind everyone joining us online that you are participating in the webcast called 3D BIM for Substations, Driving Efficiency from Design through Operation and Maintenance, which is being brought to you by Bentley Systems. We're now going to move on to the question and answer portion of today's presentation. For those of you online, if you have not already done so, please enter your questions into the Ask a Question area near the bottom of your presentation screen. We will respond to as many questions as time allows. And it looks like we already have a couple of questions. Tom, can you quantify Pestech efficiencies when designing with BIM processes?
Yes. So far, we have only successfully implementing the phase 1, which is the electrical functions design. So by having the automatic generation tools, we actually save our time on generating the bill of material, the component cross-referencing, and also the generation of the part list. So I would say this at least saves 30% of our engineering time. And a part of that, we're also using the Substation intelligent tools to generate the wiring list, cable schedule, and cable block diagram. So with this, we actually save a lot of manually produced time by having automatic functions of the software. So now what our secondary design engineers do is only check on the output of the software rather than they pick up all the wire and the cable from the schematic diagram. So it's a wonderful tool for us, especially on the substation secondary design.
Okay. And are owners taking advantage of BIM? What is their main focus for BIM design?
Yeah, as I mentioned in the presentation slide, the utility owners are not really keen at the moment to adopt BIM. So it is more like our initiative to promote the BIM concept to the utilities or to the owners. So we think that by doing this, we can differentiate ourselves with other EPC contractors, and at the same time, we will have the opportunity to educate them how important is the BIM, especially onto their asset lifecycle management or maintenance. So we think in the long run, they will consider BIM implementation as a mandatory requirement in an EPC contract.
Okay. And from your presentation, it sounds like BIM is just wonderful. It solves so many problems. But one of the questions we just received is, does Bentley Substation require a lot of training?
Yeah, that's true. For BIM implementation, it's actually a transformation of the way we work from traditional to an intelligent way. So it requires a lot of training of our staff. And this, the top management has to ensure that investment is being placed to train the engineers, to train the administrator, as well as to recruit expertise to trainers. So I wouldn't say this implementation is an easy approach, but it is definitely achievable.
Okay. Now, what is the number one way that BIM has made your job easier?
Oh yes, BIM have helped us to save a lot of drafting time, especially as a designer. I don't have to redo or manually create a symbol of a drawing. So, for example, whenever I need a transformer symbol or a transformer model, I can actually click from the library or the database. So this saves a lot of time, and we don't have to browse through our previous project to look for the similar symbol or the similar drawings. This actually cut down a lot of errors. And the most beautiful part that I like about this BIM is it can actually generate a lot of deliverables, which is a drawing output, which in this case, most of our engineers spend a lot of time in preparing the bill of material, preparing the schematic cost referencing, preparing the part list, preparing the wire list, cable schedule, so on and so forth. And instead, the time they spend in design are very minimum, but they spend their time mainly in generating of output, design output. So this is the most wonderful part that I like BIM to be implemented in the substations. And also, not to forget that the information sharing is another important and beautiful part of BIM implementation. Currently, our company does not have information sharing, whereby a lot of engineers are carrying with them the design drawing. So with this, oftenly when a customer requests for any updates, we have to wait for the respective engineer to work on it. Whereas if we have an information sharing or information management system, we can actually easily call from the server or the database available in the company. So this is another advantage of having BIM. And I think the last part of BIM is it actually makes us different with other EPC contractors, whereby we help the utilities to prepare all the database, all the O&M manual, and all the FB drawing easily without requiring them to keep on emphasize or reminding the contractor to deliver what they're supposed to deliver. And this saves a lot of time when we come to the project handover. So I think these are the advantages and benefits of having BIM implementation.
Okay, thank you, Chong. And thank all of you for the great questions today. Chong will take a look at the questions that we were unable to get to during this webcast, and he can email his responses to the individuals who asked those questions. And that's going to conclude our presentation, 3D BIM for substations, driving efficiency from design through operation and maintenance. If you'd like to review today's material at some later date, an archived version of this event will be made available on our website at www.elp.com. Once again, thank you, Chong, for being a part of today's web presentation. And I'd also like to thank Bentley Systems for sponsoring this event. And as always, thanks to those of you who joined us remotely for making time in your schedules. I'm Kristen Wright for Power Grid International and Electric Light and Power Magazine. Enjoy the rest of your day.